here I have 0.031 moles. Okay? So now, let me put this over here. SO2, NO, and SO3. So I'm going to go ahead and erase this because I don't have space. Now that we know the moles, we need to find the mole fraction. Okay? So X, large X equals the mole fraction. I'm just going to put what it is for each gas, so I make sure I'm doing the right thing. All right, so we know that it's simply just the moles of the gas itself over the moles total, okay? 0.403 moles, and over here, 0.031 moles. So I just moved these numbers over, okay? Now, the last thing I do is I take this number, and this number, and I add them because I want to know the total of all the moles, okay? And that is 0.668 moles, okay? So I use this number for each one, 0.668, 0.668. We're close. Now, moles cancel on each because we know the mole fraction is just simply a number. It doesn't have any units attached to it. So when I crunch this out of my calculator, I get 0.350. This one, 0.603, 0.046. So these are your answers for each one of these gases, okay? So really quick, let's just review that. They gave you grams of each substance, each gas. So you took those grams, you already know how to do that, and you found out how many moles of each you have. And then you put the moles of each on the top, added them together to find the total. It's moles over part over total. You divide them, and that's how you get your mole fraction. Okay? So that was number 5. All right, let's look at number 6. I'm going to keep this up here for a second because it has to do with this one. It says, if the total pressure of the gas mixture in the problem above, this problem, was 1.1 atmosphere, what was the partial pressure of each gas? Okay, so I'm going to put this, I'm just going to rewrite this over here so I can use the space on my other side of my board. SO3. Okay, so remember, this is the mole fraction. Now, they gave me a total pressure. So I have a total pressure and a mole fraction, and I need to find a partial pressure of each gas. So I'm going to look at my equations up here, and I should see that this one, I get a partial pressure with the mole fraction and the total pressure. Okay, perfect, because I already have this. So let's just go ahead and do this one for each. So I'm going to put SO2. So here's my mole fraction, 0.350 times, and they said 1.1 atmospheres. That's what was my total pressure. So I'm going to do this for each one, PNO and PSO3. So I have 0.603 times, same thing, 1.1. 0.046 times 1.1 atmosphere. So I know my answer is going to be in atmospheres. I don't need that anymore. So all I have to do is multiply these numbers, and if I do that, I get 0.39 atmospheres for the first one. I get, for NO, I get 0.66 atmospheres, and for SO3, I get 0.051 atmospheres. So really, we just took the mole fraction we found from the previous problem, and we stuck it in one of our other equations to be able to find out the partial pressure. So you should kind of get the feel now in this module, we're really just taking the same units, pressure, volume, temperature, moles, grams, all that stuff. We already know a lot of different ways to move things around, right? And so we're using these equations that we have to, basically they ask us, can you find this? And we say, we sure can. We just need to move things around and plug things in, okay? So let's look at number 7. Let's erase this. All right, number 7 says, a steel container is filled with 5 atmospheres of nitrogen, 2 atmospheres of oxygen, and 0.50 atmospheres of argon. What is the total pressure in the vessel and the mole fraction of each? Okay, so total pressure, that should be pretty easy. They gave you a pressure of each. All you have to do is add them together. Okay, So if I have pressure total, it's going to be, they said 5 atmospheres for the first, plus 2 atmospheres for the second, plus 0.05 atmospheres. So in total, that is 7.50 atmospheres. So that's your total pressure. But that's not all they asked for. They wanted the total pressure, then they said also, what is the mole fraction for each gas? So let's look up here. I know that I've got mole fraction, total pressure, and I know my partial pressure. So I'm going to use this, okay? So I have P1 equals X1 P total. I'm trying to solve this guy, okay? So I'm just going to go ahead, move this with algebra. So this is how I'm going to find it. I just need to take the partial and divide by the total for each one, okay? So X and let's see, what were the, N2 is the first one. So for N2, this is this one, I've got 5.00 atmospheres. That's my partial over my total, which we just found, 7.05 atmospheres. I'm going to do this for the next one, the O2. So O2 is this one, 2.00 atmosphere, and I put it over the total. So you should kind of be getting the hang of this by now. Last one is argon. So 0.50 atmospheres over the total, 7.50 atmospheres. Now, just like the moles canceled out when we were finding the mole fraction, the atmospheres cancel out here. So I just go ahead and divide. Here I get 0.667. Here I get 0.267. And here I get 0.067. So you can see for this problem, we started with just one thing. We just knew the partial pressure of each, okay? We were able to take that partial pressure and find the total pressure. And then, because we knew both, we can just simply take the partial over the whole and divide, and that gives us our mole fraction, okay? So these are really useful formulas. You can really go back and forth between them. All right. Now that we've kind of worked with those first couple formulas, now we've worked with a little bit of the partial pressure and the total pressure and the mole fraction. Now we're going to kind of put it all together, and we're going to be talking about the ideal gas law, perv nerd, okay? So really, we're just going to be listing out everything that we know, and we're going to solve for it. I think we have one that's just a straight perv nerd problem, and we're just putting things in and crunching it out. But the next two are going to involve a little bit of stoichiometry. They're kind of like the culmination of the module. All right, so let's go ahead and look at number 8. It says, what is the volume of 16.1 grams of chlorine gas at 1 atmosphere and 25 degrees Celsius? So let's go ahead and put perv nerd up here. Perv nerd. Remember, pressure, volume, this is number of moles, this is our constant for our gas constant, and then this is our temperature, okay? So off to the side, I'm going to say, okay, P, V, N, R, T. And then I'm going to say, which one are we solving for, okay? So they said, what is the volume? So right away, I'm going to put a question mark. That's what I'm looking for. So let's just get that by itself, okay? So if I do that, this is how I'm going to be plugging it in, like this. All right, so right away, let's go ahead and put our constant in here. By now, hopefully you should have this memorized. We've used it a ton, okay, in our problems. It's the one with all these units, because remember, we need them to cancel out. All right, so they said, so here's our T, our T, our temperature, they said, what was our temperature? 25 degrees Celsius. We know we can't use Celsius, so I'm going to take my 25 degrees, add it up here, so I'm going to end up with 298 Kelvin. Searching for this, my pressure, they gave us 1 atmosphere. Plug it in. The last thing I'm looking for right here is my moles. Now, if I look here, they didn't give me moles, they gave me grams. That's fine, I can take grams and find moles. So they said 16.1 grams of chlorine gas, okay? So that's going to be my springboard. I'm just going to go ahead and take my moles off here. Chlorine is 35.5, so I have 2 of them. That's going to be 71.0. So if I crunch that out, I'm just going to go ahead and put that answer right here. That's where my moles is, 0.227 moles. Okay, so if you take a look quick, they gave us this, and we found this. We already know this, it's a constant. And then we took grams they gave us and found moles right here. So we are ready to go. We can just plug everything in from here on out. So my volume is going to be number of moles. Plug that in, 227 moles. Plug in your R, 0.0821 atmospheres. It's annoying to have to write all this out. I get it. And last one is temperature, 298 Kelvin. It's all over the pressure, which is 1. That's nice. You don't have to divide. All right, so cancel your